Hello everyone, so welcome back to this channel once again. And in this video session, I'll discuss the API that we can use to just zip the file in the IFS. So earlier in my previous videos, I discussed various methods like using QShell command jar, Java archive command to zip the file or unzip the file, or we discussed about copy to ARCF or copy from ARCF to zip and unzip the file. Now this time I'm going to use the IBMI API that is available by the IBM uh, so that we can zip the file. So I'll create a next video where I'll use another API that will unzip the file. So for now, I'm going to give the demo to zip a file in the IFS using the IBM API. So basically this program I've written. So you can see that QZipZip is an API or the procedure that we can use to zip a file or the folder within it or the folders. So let me show you the program. So before going into the program, we have some basic information about how we are going to use this API. So basically, this is the service program where this API is available and it's written in C program. So this is the service program of attribute CPPLE. So if I do DSP srvpgm here, QSYS, so you can see that module QZIPUTIL is available here. And now let me show you this one. So QZipZip and QZIPUnzip APIs are there. So this is used for the zip purpose that we will be going to use. So for that purpose, we need to bind this in our program whenever we want to use this API in our program. So we need to bind this service program to the program either through the binding directory or through direct bind during the call runtime during the compilation time. So this API has 5 parameters. So this was the first information that I want to mention here, that is this is available in this module or service program. And now this has 5 parameters. First parameter is file to zip. Details means the file that has to be zipped. So that details goes here, including the path and the file name. And second parameter is the zip file details, means zip file path or the zip file name. Third one is the format name. So the format that will be used is zip 00100. And fourth is users zip options. That is the options that user provide in this format. Subfields. So this would be a data structure, error data structure. And the last thing is the error data structure. If any error occurs, that will be returned to this structure. And these two would again be data structure. I'll let you know how that would be defined. Now to prototype or use the prototype of this API, we do have this library QSYSINC / QRPGLESRC is the location where QZIPUTIL is defined, work member PDM. So let's search QZIPUTIL. So here, if I do go at the bottom, You can see the prototypes are defined here, QZipZip, QZipUnzip. So this is the prototype of this API, files to zip, zip file name, format name, zip con, options, and array structure. So you can see these two are the data structure and they are defined like DSQLG path underscore name underscore t. So this would be a template, and this is again a template QZip underscore zip options underscore t. So I think this is defined here itself. You zip options. This one. And so if you notice that these data structures would be using qualified, means the subfields will be qualified, and they're using template and align keywords. Template align is basically aligning the float or numbers things, and template is basically that no one can use a piece of this data structure. So one has to define a data structure in their program and using like DS to this template, and then they can refer or they can use the subfields of their substructure like this. Sub data structure subfields like this. So one more thing here is you can see that here they have defined slash copy, QSYSINC, and QRP in QRPGLESRC SYSTYPES. Why they did this? Just because they are actually referring to the QLG underscore path name underscore T data structure here in this API. So let me search that too. So we need to include this too. You can see this is the data structure that they were referring. So basically file to be zipped or zipped file name would be containing this, would be having this data structure and these subfields. So I don't think that needs to be included here just because that is already included there in the in the QGPutil. The QGPutil contains this types, and we are going to copy this QGPutil inside our source program using slash copy option. And then what we are doing is we need a data structure, array structure as well, because this one is having the last parameter as structure, and we basically use the standard as structure QSEC, QUSEC. Let me show you that as well. This is the standard common array data structure, QUSEC, and this would contain the message ID or the error that one wherever it comes. Now what I will do is, as we saw that, just let me open this, then you will QZiputil. So you can see that these two parameters are defined using like this, and this was defined in this is types, and that is already included within it using slash copy. And so the same way, we also define our data structures here using the same QLG underscore path underscore name underscore d using like ds, and we initialize using the like ds. So both the data structure that we have defined here will be like ds, the same ds defined inside the SYSTYPES in QSYSINC slash QRPGLESRC, and that QSYS type is included within the QZIPUTIL. So we have included the QZIPUTIL here. Now the third parameter is the format. So we given the zip 00100 format, and we define the ds as QZIP underscore zip underscore options underscore zip 00100t. That is defined inside the QZIP util. So this we can see that QZIP underscore zip 00100 is defined using this like ds. We are actually doing like ds on this one. And if you see this one, this has these fields: verbose option, subtree option, comment length. That's why we are doing like ds to that ds or this div format. So these are three parameters for which we have defined the ds in our program. As you can see, first, second, and third. And the fourth is itself the format values, format name values that we are defining here. Zip 00100 format ds, so its value will be the fourth option, and the fifth option is the error that we will pass, that is QUSEC, that we have already included within our program using the slash copy in the copybook QUSEC present here at this location. Now, as I already showed you in the QZIPUTIL, that these two are actually pointing to this data structure subfields, or referred from this data structure subfields. Now they have these fields: species ID, country ID, language ID, reserved, path type, path length, path name, delimiter reserved to path name. So I won't be using all these parameters here, and I would be introducing only the path name and of course path length parameter, and will be defining all of this or initializing all of this parameter with the default values. So you can see that file to be zipped. I'm first initializing the first ds, file to be zipped dot ccs id, country id, language id, reserve, part type with the default values and with the delimiter slash. Now path name is the pf1.csv. So if I do work link here at my current location, we have pf1.csv that is available. So I'm going to zip this file. So I'm passing the actual length of this file by trimming and getting the percent length and putting it inside the path underscore length of field of this file to be zipped variable. Now this file to be zipped is populated. Now what I can do is I can directly initialize the zipped file with this file to be zipped, because all parameters would be same. Only the path would be default and the length. So the path of this zipped file I have given pf1.zip, because here this was pf1.csv, this was pf1.zip, and this is the length of the file. Now these two are complete. The third point is format. So now I need to initialize the format. So format has these fields that I already shown you. Now what I can do is I can provide the values here in this subfields of this format data structure. So I'm providing the default values for now, star none, blank for comment. I don't want to give any comment, so length is again whatever the comment would be for that. For subtree option, I can pass a star all to save and zip all subfolder and file and files within them. And verbose is just to send output to the standard output. As IBM does not handle any error out of it, so one has to do the things at their in their program. Now the final thing is now we have the format available, the file to be zip data structure populated, initialized, zip file data structure initialized, format initialized, three parameters are initialized. Fourth one is the name. As you can see, the third one is the name and the fourth one is already initialized. And the structure is always we pass QSYS. So now we call this QZipZip API. So the first thing is the file to be zip, that is CSV file, and then the zip file data structure, and then the format name. The format name we have is zip 00100 format that we have defined in our program. And this one is the value of that. So basically options that we want to provide. And this is the QUSEC array structure. So once this call is complete, either it is success or it is an error. So if it's an error, we do have QUSEC, we do have fields QUSEI within the QUSEC array structure, where we can check for 1 to 4th position, that if it is CPFA means it's an error, and we display the error. From QUSEC, all errors starts with CPFA. So and at last the last record indicator sets to on and the program ends. So let's first just come out of the program, just compile it. The module is created. Let's create the program. So zip API, zip API. What we need to do is we need to bind the service program QZIPUTIL. You can set this call. Program zip API created a library this PSPPGM zip API. So we can see this module is bound. This service program is again bound to this program. Now we can debug this. Zip API. Just call zip API. So you can see that it is just initialized with like this. Now I'm initializing this with the default values. So you can see this is defined initialized with the default values, and the path length is 7 and the path name is pf1.csv here. Now zip to file is again not initialized. So Now it is initialized with the whatever value we have in the file to be zipped. But here the path name should differ. So we are providing the path name. So the path name is pf1.zip. Now you can see I'm providing the values to the options format. So I can show you the values star blank, length is 500. Now I'm passing all these parameters as in the required format. Files to be zipped, zip file, the format name, the format value, and the error data section. So error data section, you can see if any error, this field will get populated with CPFA star. So you can see that it is now called, and let's see. So there is no error reported in the data set, in the error data structure, and we come out of the program. So now just do work link to see. So earlier we have pf1.csv available. Now you can see pf1.zip is created. Now this was created from a CSV file present in the IFS. So we just actually created the GIF file using the CSV in the IFS. Now I want to create a GIF file from my DDS file, let's say PF, having some data in my actual library. So I want to create a zip file out of that. How would I do that? The same program will be called, let me show you, just call it again. What thing I will do is just press. So you can see PF1 is available in work object PF1. So this file is available in Easy Class 1 library, and we have passed the path as pf1.csv. Let's take F11. So it is pf1.csv. Now let me give the qualified path name to the pf1.file that we have in my Easy Class 1 library. So how would I give that? /qsys.lib /easyclass1.lib/pf1.file. So now the path that I'm passing is from my library, that file pf1. This time not CSV. That is present in the IFS, so I'm not passing that. So I'm passing a file which is present in my library easy class 1, and the file name is pf1.file. And this is the length that would get copied. So let me show you what value we have now. So the length is 33. So this is holding 33 length, and the delimiter is slash. Now a zipped file would also be the same values, but what I will do is I will pass, instead of pf1.zip, because pf1.zip is already available on the IFS path, pf2.zip. Let me show you work link. pf2.zip is not available. So this is the length. We show you the file. So it has length 7, and the path, or you can say path, or the file zipped file name is pf2.zip. Now I'm populating the format again with the same way. This is the path of the file that is to be zipped, and This is the zip file name. This is the format and the format name. And this is the error data section. Now let's take F10 so that this API gets called. If this API gets called, QUSEC gets populated. So there's nothing, no error. And once I and debug, just do over click. So you can see that tf2.zip is created. So this way you are able to do the zip or create the zip file in any way using this API, and that is very easy to code. There's nothing hard in it. A simple way to just follow the way that it was built, and that's all in this video. Thank you and have a nice time.